Hello, Algebra students. We are going to continue Module 4, and today we're going to talk about piecewise and step functions. So in your vocabulary sheet, you should have in the center the native language column again, and this is where you're going to put your picture definition to help you understand what this all means. For the first one, piecewise, defined function. Think of whenever you piece something together. And this is what this is going to look like. It's going to look like pieces of lines. So this is a function that's defined by at least two subfunctions. And each one of those is defined differently depending on the interval of the domain. So they're together, but they look a little bit different. So I'm going to give you a visual example about what this looks like. All right, so this is made of two different functions, and I want you guys to focus on this. Here are the equations for the two different functions, and you have to name the domain and the range for each of them. And the best way to do that, I'm going to show you two different methods, is you can use a table to see what the interval is. So we're going to go ahead and use a table for that. So in the first graph, in the 2x plus 4, where x is less than 1. Now notice, I want you guys to notice that everything in x is less than 1. So they use 1, 0, -1, -2, and -3. And then all you do is fill in your different functions for that, and you graph that with the table. So your graph that 2x plus 4 looks like is here. All right? So your graph is right there, and we're doing these equations. So you can imagine that if you graphed the other equation, which is -x plus 3, and x is greater than 1, you're going to create another table, then you're going to create another graph, and then because x is greater than but not equal to 1, you're going to place a circle at 1 and 2 to indicate that the endpoint is not included in the graph. Mainly, they're not together. So the domain for all real numbers is the range is y has to be less than 6. So this is what a piecewise graph looks like. So in your example, you can create this graph right here with these two equations. And remember, one is less than or equal to 0, and the other one is greater than 1. So this is an example of a piecewise function. All right, our next definition is a piecewise linear function. And hopefully you can determine that it's going to be two pieces of a function, but they're both going to be linear. So the definition is a function defined by at least two linear subfunctions, each of which is defined differently depending on the interval of the domain. So I'm going to give you a picture of what this looks like. Okay, exact same equations. I want you guys to notice that. So these are the exact same equations, and they're linear. So this looks exactly like the piecewise defined function, and they're both linear because they have the same types of slopes involved with them, and they cross each other. So if you remove any part of it, so this means that if the function of x is -3 plus 3, you're going to graph. Here's where you're going to graph it in the very same thing that we did. And notice the circle is right there, which is where it began from your tables. And you're going to use this method to graph the function. And because x is greater than but not equal to 1, you're going to place a circle where the x equals 1 to indicate that the endpoint is not included in the graph. So your endpoint is not included in the graph. Notice that it crosses here. You guys want to make sure that whenever you define these, that your range of numbers is not where it crosses the graph. And that's the big difference between defined functions and linear functions. Defined functions can really be any equation. Linear functions, of course, have to have basic intervals. So these are all lines. All right, on to your third vocabulary word, which is a step function. And a step function is a lot like a piecewise linear function with a graph that has a series of horizontal line segments. So it looks a little bit like a step. I'm going to show you guys an example of what that might look like and how you would graph that. All right, so this is what a step function looks like. And notice, I want you guys to notice something that you see x is in brackets. So what they want you to do, this is your next one, your greatest integer function is kind of part of the step function. So a step function is a type of piecewise linear function with a graph that is a series of horizontal line segments. And one example is the greatest integer function. So the graphs are disjointed, the domain is all real numbers, and the range is all integers. So this is and it looks like, I don't know if you guys notice this, it looks like stairs going up. So this is a really good visual example of what a step function looks like. So I want you guys to put that into your notebooks. And then finally, let's go ahead and fill in our definition for the greatest integer function, because it goes along with the step function. So you don't necessarily need to do a visual example, but you might put in your native language notes that it looks the same. So the greatest integer function is a step function in which the function of x is the biggest integer less than or equal to x. So if the function of x is 1, then the greatest integer has to be more than 1 or more. So it can be 2 or 3 or 4. And then you connect those horizontal lines together, because of course, if there's no y-intercept, then your x is always, your y is always equal to x. So that's how you get that horizontal line that goes across, and you do it in pieces and they go up like a step. So I want you guys to think about the two questions on the bottom. What is the difference between a piecewise defined function and a piecewise linear function? Hopefully you notice that a linear function has to be in a straight line, and a defined function are just two defined equations that you graph. And then number 2, it says, how are step functions and greatest integer functions related? Well, they're related because it goes in a step, and y is equal to x. That's how you get that horizontal line. One way to get a step function is to use the greatest integer function in order to do it. Make sure you put your vocabulary in your yellow notebook in the prongs so that I can find it. Also, make sure that you have really good visual examples in that native language. Of course, your piecewise defined and your piecewise linear can be the same. Your step function and your greatest integer function can also be the same.